All right. So, hey, today we're going to look at electron configuration again, guys. And then we're going to look at electron configuration. We're going to look at noble gas configuration. We're going to learn how to draw the model of the atom based on the electron configuration that we have. We're going to look at valence electrons. And then we're going to also try to uh, draw the atom. Okay. All right. Here we go. So let's start. For example, guys, let's say we have aluminum. All right, so let's take for example we got aluminum, Al, Al. All right, so we want to first write the electron configuration for aluminum. Okay, first thing you need to figure out is the atomic number, which is 13, minus the charge. All right, it's super important that you know that you have to take into consideration the charge. All right, so this one doesn't have a charge, so it's 0. Therefore, you got 13 electrons. Okay, so again, if you don't have a charge, okay, it's going to be exactly the same box as is on this table right here. So that means our goal, our target, we have 13 electrons is box number 13. And where is that? It's right here. All right, right there. Okay, so now again, we have to write down everything starting from box 1 all the way to 13. But again, we only have to write down those in the shaded boxes plus our target box. So let's look. So box number 1, do we write it? No. Box number 2, do we write it? Yes. Therefore, I need to write that down. So it's going to be 1s2. Okay. Box number 3, do I write it? No. Box number 4, yes. And again, it's right there. So this is 2s2. Okay. Box number 5, no. 6, no. 7, no. 8, no. 9, no. 10, yes. Again, I'm writing down only those in the shaded boxes. So this is 2p6. Okay. How about box 11? No. Box 12, yes. Okay. Box 12 is a yes. Therefore, you need to write down 3s2. Okay. And then finally, box number 13 is our target. Therefore, this is 3p1. And we're done. Okay. We're actually done. All right. Again, guys, how do I check? You can actually check if this is correct by adding up all the exponents. Okay. So this is a 2 plus a 2, 4 plus a 6 is a 10, plus a 2 is a 12, plus 1 is a 13. Okay. And that should equals to your total number of electrons, which is 13 right there. Okay. All right. There you go. All right. The question now is this. Okay. The question now that a lot of people have is this. Why do we do this? Why do we do this? Well, again, guys, the electron configuration tells us how we distribute the electrons outside the nucleus. All right. So how can we tell from this electron configuration how the electrons are distributed outside the nucleus? All right. So again, we learned earlier, guys, that the big numbers in front tells you the energy level. So look, we can say that 1s2 right there is in the first energy level. So this is the first energy level. Okay. So this one right here is in the first energy level. Okay. All right. We also learned that the exponents tell you the number of electrons. So if you look at the first energy level, you can clearly see you have 2 electrons. Okay. You have 2 electrons in your first energy level. Okay. All right. Now look at the rest. Okay. If you look closely, guys, there's 2 of them that has a big 2 in front. So again, there are 2 configurations that has a 2 in front, 2s and 2p6. Therefore, they're both in the second energy level. So this is in the second energy level. Okay, and we'll just write down EL for energy level. Right. So how many electrons do we have? Guys, since they're both in the second energy level, we can add them. 2 plus 6 gives me 8 electrons. Okay, so give me 8 electrons. All right, do you see where I'm going now? Okay, so look, the next two will have the same Big number in front, 3s and the 3p. Therefore, they're both in the third energy level. Okay. And same as always, the exponents tell you the number of electrons, so you just add them both up. So you got 3 electrons for the third energy level. Okay, all right. So now we can actually draw a sketch of our atom. So let's do a sketch. So now we know that there are 3 energy levels. So let's draw the nucleus. And we got our first energy level. Okay, right? That's our first. Okay, we got our second energy level. So that's going to be our second. And we got our third energy level. This is going to be our third. Okay. And then now we can distribute those electrons in each energy level. So look again. In the first energy level, we have 2 electrons. So I'm going to put 2. 1, 2. See it? In the second energy level, I got 8. So I'm going to put in 8. 1, 2, 3, 4, 5, 6, 7, and 8. See it? And finally, in the last energy level, I got 3 electrons. So I'm going to put in 3. 1, 2, 3. You see it? So based on the electron configuration, we can actually draw our model, our Bohr model for the atom. All right. Okay. All right. See it? Okay. Now, wait a minute. Wait a minute. Wait a minute. Wait a minute. Okay. All right. So, okay. Right. Let's go back. So, based on this, guys, all right, let's do the noble gas configuration. Noble gas. Okay. You should have also learned how to do the noble gas configuration. Remember? So this is the electron configuration. Let's do the noble gas configuration for this. Remember, the noble gas is you look for a noble gas before the element. So in our case, our target is Al, right? Right there. So what's the noble gas before it? It's Ne. All right. It's Ne. And then you just follow exactly the same rules that we have. You just write down those that are in the shaded boxes plus your target box. So our noble gas configuration is Ne. Okay. Box number 11 is no. 12, yes, so it's 3s2. Okay. 13, 3p1. Okay. And this is our noble gas configuration right there. So again, this is your standard form. Okay. This is the standard form. And this is our noble gas configuration. Okay. All right. So someone's going to ask, oh, Mr. Chua, why is it important to get the noble gas configuration of the atom? Well, guys, if you look closely at the noble gas configuration, you're going to see that the last thing that you wrote down after Ne right there is the elements, I mean the electrons in the third energy level. See that? This is the third energy level. Third energy level is your outermost energy level. Okay, energy level. And how many electrons we have here? We got 3. Okay, 3 electrons. It's right there. 3 electrons. Guys, we call this valence electrons. Okay, valence electrons. And these are electrons, okay, in the outermost energy level. All right. So why is this important, guys? The valence electrons are actually the electrons that are responsible for bonding. So we have here, guys, 3 electrons. See it? Okay, let's try it again. Let's try another example. So for example, guys, let's say I wanted to find we'll do the standard form and then the noble gas notation, right? So for oxygen, so let's do oxygen. Oxygen, guys, has atomic number 8. Again, the charge is 0. 8 minus 0, you got 8 electrons. Okay, again, guys, our target is right here. See it? So again, I start with box number one. I don't write it down. Box number two, yes. Therefore, I have 1s2. Okay. Box number three, no. Four, yes. I need to write that down. So I got 2s2. Okay. Five, no. Six, no. Seven, no. Eight is a yes. Okay. And again, I need to write that down is 2p4. Okay, I'm done. You see it? All right. All right. So let's do the noble gas configuration now. All right. So if you look closely, guys, at the noble gas configuration, okay, again, guys, our target is oxygen, right? So again, the rule is you have to find the noble gas before it. So if you look for the noble gas before it, it's going to be He, this one right here. So I need to write that down. So this bracket He, right? Remember, since you wrote down He, you don't write down 1s2. You don't write down 1s2 anymore, right? And then you just move on, and that's going to be your new starting box. You just move on until you get to oxygen, okay, box number 8, okay, and do exactly the same thing you did before. If it's unshaded, you don't write it. If it's shaded, you do. So box number 3, do you write it? No. 4, yes. Therefore, I have to write down 2s2, okay. 5, no. 6, no. 7, no. 8, yes. 2p4. And that's my noble gas configuration right there. Okay. All right. So, again, let's try to interpret this. Let's try to interpret everything that we just wrote down. Okay. All right. So, let's start on our standard form. So, this is, again, guys, called the standard form. Okay. All right. So, again, guys, I got 1s2. That means this is in the first energy level. And I got 2 electrons. Again, how do I know? It's because of the big number in front tells you the energy level, and then the exponent tells you the number of electrons, right? Look at the next one. Remember, since they both have a big 2 in front, they go in the same energy level, and they're both in the second energy level. And again, guys, the number of electrons will be the exponent. So this is 2 plus 4. That gives me 6 electrons. You see it? All right. Guys, if you look closely, again, let's divide this into two. And again, guys, this is our noble gas configuration. Okay. If you look closely, guys, based on our standard form, all right, this is your outermost. Okay. This is your valence electrons. Okay. Again, valence electrons are your outermost electrons in the outermost energy level. All right. So we can actually draw this. Let's draw this. So if you draw the Bohr model for this is the nucleus. You got 1. That's your first energy level. Let's put first. And you got 2. That's your second energy level. And in the first energy level, you got 2 electrons. And in the second energy level, you got 6 electrons. Okay. And again, guys, this is called the Bohr model of the atom. Okay. All right. So, guys, if you look at our noble gas configuration, you can still see that exact same thing that you have 6 valence electrons right there. See it? Okay. So again, this is your 6 valence electrons. 6 valence electrons right there. Okay. All right. Is there a better way of representing valence electrons? Yes, there is. It's what you call, guys, your Lewis dot diagram. All right. So this is called the Lewis dot diagram now. So this is called the Lewis dot diagram. All right. To draw the Lewis dot diagram, guys, you just need to draw first the symbol for the element. In our case, it's oxygen. Followed by, guys, the valence electrons, all right, represented as dots around that symbol. Okay, so you got six. So we're going to put in six. It's going to look like this: one, two, three, four, five, six. And this is the Lewis dot diagram for oxygen. All right. Okay, shortcut time. All right, let's do some shortcuts. Okay, guys, can you tell the number of valence electrons really quickly without doing the electron configuration? Yes, you can. Just by looking at the group number. All right, by looking at the group number. I don't think we have a periodic table here. Okay, so if we get a periodic table, guys, if we get a periodic table, you can actually look at the periodic table and get the group number and get the valence electrons there. For example, okay, let's take for example, let's say you have nitrogen. Okay, let's take for example you have nitrogen. So look for the periodic table. The symbol is N. Okay, all right, and then you look up. This one belongs in group. Okay, 15 or 5A. Okay, see it? So you have to look at the group number in the ones place. So what is it? It's a 5. Y'all see it? Or 5A. Therefore, nitrogen has 5 valence electrons. All right. So therefore, we can now draw our Lewis dot diagram. It's going to look like this. It's going to look like N with 5 dots around it. 1, 2, 3, 4, and 5. And that is how our Lewis dot diagram for nitrogen looks like. Okay. All right. Okay. Let's try another one. All right. All right. So let's try another example. All right. For example, let's draw the Lewis dot diagram, for example, for phosphorus, P. Okay. P. Okay. If you look at the periodic table, guys, P is right here. See it? Okay. And what's the group number here? 15. So again, guys, you have to look at the number in the ones place. So therefore, this has 5 valence electrons. Okay. And now we can draw our Lewis dot diagram. So how do we do this again? First, draw the symbol P, followed by 5 dots that you will put around it. 1, 2. Okay. Put the first 2 at the top, and then you go 1 each side first. 3, 4, and 5. So this is the Lewis dot diagram for P. You see it? All right, let's try another one. For example, guys, I wanted to put in, for example, Ca, calcium. Calcium is right here. And the group number, if you look closely, is 2. Again, since we need to look for the number in the group number in the ones place, 2 is already it. So 2 valence electrons. Okay. Therefore, I need to draw this. So Ca will look like this. Ca, and then again, 1, 2. And that's it. Because you have 2 valence electrons. All right. Hopefully, guys, this helps you out. Again, if you have any questions, just email me. All right, and then watch the videos in the modules. That's going to help you out a lot. All right.